Industry 5.0 Plus, let's talk with machine. On this screen, we can see one of the possible user interface screens in Industry 5.0, where AI controls a network of multi-feed cameras to create a complete, real-time view of the factory floor. Unlike the cameras used in Industry 4.0 that primarily inspect products, these cameras cover every corner of the production area to track all motion. By doing this, the AI is able to predict potential issues and prevent any damage or possibly production stop before it even starts. Now let's open up the main screen to visualize this new concept. The main panel itself is a transparent display with adjustable transparency controls. This allows us to see the live camera feed in the background, even while interacting with the AI, and it also allows us to adjust the transparency depending on the video streaming in the background to be able the same time to see camera feed during chatting with AI. On the top right of the screen, you'll find the status report. This is a critical component, offering a real-time view of the AI's communication network. You can see live updates on all the essential nodes, executors, workers, and camera controls. It's designed to give you a clear visual representation of the real-time communication happening between all the AI models, a truly vital aspect of this system. Directly below that, on the bottom right, is the information status section. Here, the AI is constantly working, updating, and informing us about everything happening across the entire production floor. It intelligently gathers and presents all the crucial information, ensuring you're always in the loop about the complete production status. Now let's move to the left side of the screen where we find the main AI interface, which we've named Ali. You can interact with Ali through text or voice input. For this demonstration, we'll be using voice input as it's much more efficient for our current task. Create scene. Let's assume I've just walked into the control room and it's the start of my shift. My first priority is to get a complete overview of what happened overnight and prepare for the day ahead. So my very first command to the AI would be to get a summary of the shift transfer. Ali, generate shift transfer summary. Period, 12 hours. Include all warnings, errors, and informational events. On the screen, we see a shift transfer summary that outlines key updates from the production floor. Production overview. A total of 3,752 units were successfully processed. Maintenance advisory. Line 2 reports that gripper unit AGP012L is nearing its life cycle limit. Show me a picture of the GP012L part. Show me more details and generate the technical specifications for the GP012L gripper. Ali, check how many units of part GP12 are currently used on all machines and lines in the factory, as well as the number of units and associated fittings we have in stock. Place an order for 10 units of the GP012L gripper, create the work order with installation instructions, and send them to the tech department with a preventive replacement scheduled for Monday, September 25th at 7:30 a.m. What is next? Line 3 experienced a 0.5 millimeter misalignment in the actuator tool, but it remained within acceptable tolerance. To verify this issue further, I will navigate to a different screen with a new panel layout. In this case, I'll switch to a single chat panel for focused diagnostics. Activate live feed for RTX07. I'm moving to screen 4. Ali, I'm working on screen SC4 right now. Does the RTX07 have a bumper or adjustable hard stop? Zoom in cam CX21. Show the procedure for griper adjusting or calibrate. Show max offset tolerances for RTX07. Continue monitoring the offset. If any additional offset of 0.5 is detected, display this information on the main screen. Then create a replacement request and send it to the engineering manager. Next issue encountered, Executor EX04, robot section, failed to pick up a component. Inspection is recommended. Ali, activate the multi-camera live feed from EX04, robot section, on screen 4. Ali, show the last 5 values before and after the encoder value for a pick-and-place operation when a mispick occurs. Pick-and-place position looks good. Does the controller receive a part presence signal from the bowl feeder sensor? Zoom in on the gripper's feed and pause it on screen 4. Submit a request to the DevCAD model to design a new gripper with a touchdown sensor and a part presence sensor for enhanced control and feedback, and specify the use of 90-degree air fittings. Has the part design been completed? Show Show me more details and generate the technical specifications for the GPL-14 gripper. Show me the side. Confirm the installation instructions have been updated with the calibration procedure and new control inputs. Also confirm the upgrade schedule has been communicated to the technical department. Generate a command for the code model to create the upgrade controller code for the new gripper. The code must utilize input X14 for the touchdown sensor and input X17 for the part presence sensor. This generated code will be used for the upcoming system upgrade. Following the physical installation of the new gripper, should the controller code upgrade be initiated by sending a request to the main screen? And should the system await a confirmation signal to proceed? What is next? Pneumatic alert. Sensor APS-12 indicates unstable pressure, possible loose air connection. Verification required. ALI sensor APS-12 has reported unstable pneumatic pressure, likely due to a loose air connection. A high-priority work order should be created and sent to the technical department for immediate inspection and resolution. Prompt verification is essential to prevent potential system issues. All right, I'm done here. Catch you later.
Drop the beat.